2.4, a library of parent functions. So what are parent functions? These are all functions, and if you look at the beginning of 2.5, these are all parent functions, are all things that we've already started with, like before we have any transformations, when that's just an x and a y and some sort of math. So I want you to pause the video and try to come up with as many parent functions as you can. So see, here are some parent functions. I know that I could keep on going up with a degree, and those are still parent functions. So you do have to realize I could keep going up, but these are going to be the two that we kind of focus more on. When you look at these equations, you should know roughly what the graph looks like. This, if you're confused about what this is a constant. So this would be like a straight horizontal line. So that's constant. Just this is a linear function. This is a quadratic, a cubic. Here's a square root, absolute value. So that's your v. This is a u. This is a squiggle. And then we have our irrational. So the u, this is where you have the two u's. Okay, so first, linear function. So I already know it's going to look like mx plus b. It already gives us our 2 points. This is one way of finding the points or giving you the points. So really what I'm giving you is 1 point is my input's 1, my output's 3. Other one, my input is 4, my output is 0. So this is how you have to find the slope first, because if I'm going to write my linear equations, mx plus b, so this is your difference of y's, 3 minus 0, over your difference of x's. Again, it doesn't matter which one you choose to be your y's or x or your first point, second point, as long as you have that. Now, I'm going to use my equation to find my b. I'm going to use this one because it looks like it's going to be the easiest. I can do this two ways. Y minus y1, which my y1 is 0, equal to my slope, x minus x1, which is equal to 4. And I distribute. So I get y is equal to negative x plus 4. Or if you realize that that is you could also do it by using the y equals mx plus b. And sometimes people prefer to do this way and just solve for b using one of these 2 points. Let's just say if I use 1 and 3. So I know 3 is equal to y. I know my y is equal to negative 1. So these are just two different ways that you can solve for x. My 1, so this is my x, y, that's from this point right here, plus b, and then I solve that. So that's a negative 1, so I have to add that 1 over. So I know b is equal to 4, and then plug it into my y equals mx plus b. Either way you choose to do it should give you the same answer. This one, though, steps and piecewise you must have seen before. Step functions are a little bit different. Step functions means that the graph looks like steps. Literally, that's what the definition of graph, that looks like steps. Okay, what actually creates a step function? This symbol right here is saying the greatest integer function. This right here is saying the greatest integer less than or equal to x. So again, less than or equal to. I'm going to do these first ones, and then you are going to try to do b by yourself. So if I plug negative 1 into this equation, so when I'm doing this, I have negative 1 here, and then I have a plus 1. Okay, so I'm evaluating this. So this number, what number either is less than or equal to? Well, because this is a whole number, that's what I'm trying to get to. I'm trying to get this number to be a whole number. Well, negative 1 is already a whole number. Sorry, an integer number. So this would be negative 1 plus 1, which would give me 0. So my ordered pair here would give me negative 1, 0. Same thing when I'm looking at my 2. Now, when I'm looking at my 2, it's already an integer. So I'm already taking this 2 plus 1. So when I plug 2 in, I get 3 out. Now I'm dealing with a fraction. I'm going to write this as 1.5. Sometimes it's easier for people to see that. So now in my brain, I'm thinking the greatest integer that's less than or equal to. Well, this is not an integer, so I have to always go down. I'm always thinking what's down from that. So less than 1.5 would be 1. This also has an input of 1.5 and an output. So you can write it as a fraction if you want to, of 2. So again, if I look at this last one, if I plug in negative 7/5, that's the same thing as, in case if you're not sure, negative 1.4. So sometimes it's easier for your brain to work in a decimal. So again, I'm thinking the number that's less than or equal to. No, this is a negative number. the smaller number, the less than number would be a -2 here, because -2 is less than, so that's the smallest number, less than -1.4 plus 1. So this is, I plugged in the -7/5, and I got out -1. Pause the video and try to do B by yourself. So you should have got -1, 1, 2, 4, 1.53, because it's less than, again, less than 0.6 would be 0. And the last two are parent functions are piecewise. So one thing I'm going to do, I'm going to draw two tables. It's kind of up to you how you want to do this. But we have one equation. We have this 2x plus 3, and we have the -x plus 4. For this equation, for sure I'm going to evaluate 1, because I have to have that as a point. That's a good point right here. And any numbers that are less than 1. So I'm going to do 0. If you want to do more than one number, especially depending what it is, I see that this is linear, so I'm only going to actually do the 2. And again, this is also linear, but I'm for sure going to evaluate 1 and anything that's greater than that. So I'm going to do 2. If you want to do like 5, and over here, if you want to do -3, it doesn't really matter. So if I plug these into the equation, this is what I get out. So if I plug 1 in, so that's 2 plus 3 is 5, and keep going. Now this is where you have to be careful. For this equation at 1, this is going to be a closed circle. So I'm going to draw a closed circle here. At 1 for this one, because this is a changing point, it's an open circle. Now I'm going to plot these points. So at 1, I have 5. Again, that's a closed circle. 0, I'm at 3. Closed circle, because it's including all these numbers. These are the 2 points that I had to really care about. All the other ones should be closed circles. -3, -3. So this is what I have going, because it's less than. So this one should have the arrow at the end, because it means less than 1 is over here. Now I have 1, 3. That should be an open circle. And I should clearly see that that is an open circle. If I can't clearly see that that's an open circle, then that's not good. Then 2, 2, and then 5, -1. So here are my points on the right-hand side. So this is what my piecewise function would look like. I want you to pause the video and try to do B by yourself. I'm sorry, this x should be up here. This x should be right next to, both of these are linear functions. The x should be right next to that. So your graph should look something like this. And that is all I have for this section. Have a grand, have a wonderful day.